Alright, so here's another example for class 9 where I'm going to do a problem out of Shigley. This is problem 399, serving as an example. And we have an antenna that's guided by 3 cables as shown. Knowing that the tension in cable AB is 288 pounds, replace the force exerted by at A, right here, by cable AB with an equivalent force couple system at O, right here, right, at the base, right? So what we're really doing is we're just removing one cable. We're removing this cable and moving and putting an equivalent force and a couple down here at the bottom. So if somehow there was some means of us wanting to get rid of the cable and instead replace it with something, that would be like our motivation. So first off, I'm going to get my position vector ROA, right? Okay, so that's going to be from here to there. That's going to be the moment arm, right? So if we were going to draw this thing over to the side, by the way, just to isolate the thing, here is that RO with A with respect to O. I think I should need to go with his no, this should have been A with respect to O. I can't believe I wrote it wrong. I did. No one was there to stop me. It's one of the hazards of being a professor, right? Sometimes people just don't bother to tell you. Then some students really relish in it. I think I really enjoyed annoying my professors, and so I really got it coming to me. All right. So anyway, there's our A with respect to O. Focus. Here you go. And here is the vector of the force that's being on here. It's going to go downwards in that direction, and that's going to be that cable AB from the way that we're looking at it there. So the vector, this will be 120, and this is going upwards, so it's a positive 128. That's how I knew that I had it written it wrong, because I had it positive, so it must have been there. Okay, so now cable AB, we need to go to B with respect to A. And I wrote it out wrong here too, right? So let me see if I can get anything correct today. That'd be great. Super great. All right. So I want to get B with respect to A. All right. So I need to go in, okay, so that's going to be in the negative X direction by 64 feet. And it's going to be the negative 128 feet because it's going down to the ground. And then in the Z direction, which is right here, looks like it's going positive, and it's only going to be 16 feet. These are all feet. So we want to get the magnitude of this. And I got lazy. It didn't bother, and I wrote that it was 144 feet. So there you go. So the FAB that we want to get right here, and we know how to do this. We're really good at this so far. Negative 64 over 144. I plus our 288 and our negative 128 over our 144 J, and then our 288 16 144, that's a K. So we're going to come up with values of negative 128 I, negative 256 J, and 320 K, and these are all pounds. So we take our moment that's placed on this thing, and by the way, that would be the equivalent force that we're going to be placing down at O to take care of what happened up here. But now we're going to take this A with respect to O, right, and cross it with F AB. So I, J, and K. Seems to me as if you guys must be tired of doing this at some point, right? 128 and 0. It's going to be pretty easy, actually. This one's not that bad. So we got this negative 128 from here, a negative 256.0 there. I left off the 0.0 in there, and 320. And off we go. We got that one. We're going to do I, so we do this one, do this bottom right hand corner, 128, 320, and then minus our 0, and what does it matter because it's already by 0, right? Minus, make sure we get that minus when we put it in here, and we see that we're going to go J, but it's going to be that one across that one, and that one across that one. Woo, 0, right? We didn't have to do anything. That's great. One thing you can see is that cable is incapable of making this thing spin, right? The cable didn't apply any kind of moment to make the thing spin. Therefore, it's got no moment about the Y. Makes sense, huh? And then lastly, we're going to do this little corner, downwards corner right here, times the K. So we got 0 times the negative 256. But now we're going to go minus 128 and minus 128. So minus times that. And then it's going to be the K. And so we end up getting for the MO that's on this thing is simply going to be, we find out that that ends up being 4,096 I, 0 J, and 16,380 K. And what we were dealing with, we had feet and pounds. These are foot pounds is our equivalent moment. And we have that R that we also said from up above was a negative 128, I, negative 256, J, and a 320 K. These are pounds. And so basically when we're looking at this, what that cable's doing to the thing, it is making it both positive in the about the I and about the K, right? So it's trying to make this way right here is that way about here, about this amount, and it's much more about the K than it is right here. So maybe I should, so it's like 4 times as much right there, right? And that's positive too, so it's going that way. And there's Y and X and Z, right? So it's really kind of coming in like a vector like that, and then you do the right-hand rule of that right there. So that this is really sort of the twisting motion that's being applied by that equivalent moment right there. And so there you have it. Another one bites the dust.